Good afternoon and welcome to our viewers. I am Hans Bruyninckx. I am the Executive Director of the European Environment Agency, and it's my pleasure to welcome you to the 5th session of our debate series on COVID-19 and environment and climate issues. We will discuss in this series with a number of Europe's top experts the links between the COVID-19 pandemic and the impact it has on climate and environment, or how that has been connected to evolutions in our natural environment. And today we have a session that focuses on the link with air quality and transport. And as usual, we are joined by two excellent speakers. The first one being Elisabetta VIGNATI, who is the head of the unit that focuses on air quality and climate at the JRC, the Joint Research Center of the European Commission, a very valid partner and valued partner for the European Environment Agency. Welcome, Elisabetta. And we have a second speaker, Vincent-Henri Peuch, who is leading the atmospheric component of the Copernicus Earth observation program, Europe's leading technology when it comes to Earth observation. Welcome to you both in the series. Let me frame the debate of today a little bit. I think it's important that we address the issue of air quality. As we all have seen the maps first of China, I think, and how air quality rapidly and dramatically improved in China, even in February of this year and into March and April. But very soon we started to see similar maps in Europe, where we could compare air quality in places like the Low Countries, the Po Valley, around some of the bigger cities in Europe, before and after some of the lockdown measures or other measures that were taken. And just this observation, I think, has stimulated debate on what can we learn from this? What does this mean? How do we interpret it? And what are our capacities to almost do real-time monitoring and observation of trends that have a long-term impact? So all of these things are on the table today. And we will be discussing this with our two guests, but also with you as the audience. As with every series, you can ask your questions either on the Zoom platform, but also through our social media. And we have a team in the back office that will sort through the questions and make sure that a number of the questions will reach our panelists. But without further ado now, I would like to ask Elisabetta to take the floor and to give us her opening remarks on the link between the COVID-19 pandemic and what we learn about air pollution. Elisabetta, the floor is yours.
Thank you, Hans, and good afternoon, everybody. I'm sharing now my presentation, and actually I take the things on the way around. So focusing the attention, first of all, to one of the issues, which was the relationship between air quality and the impact on the COVID-19. Just introducing the fact that the two are the major ways they are on the ground, on the table, as a possible effect of the air quality. One is the long-term effect. We know that the longer-term effect, longer-term exposure to bad air quality really is associated with many respiratory diseases and also cardiovascular diseases. So we thought that, that this longer-term exposure could also create exactly the conditions for the comorbidities for the COVID spread. But also it is on the ground, it is hypothesized that also there is the possibility that this long-term exposure is really influencing the immunological system, also favoring the disease. The second one is the short-term effect. So air pollution, and particularly particulate matter, is hypothesized to be one of the carrier of these viruses which enters in our lungs. In spite there are really RNA present on this particle, the infectivity is is not really yet well defined. Now, what we saw, and it was really quite important to notice, is that since the beginning of the pandemic, particularly in Europe, but also in China, there was this relationship that was exactly hypothesized. So the fact that the environmental conditions, and particularly air quality, was really influencing particularly the number of deaths. What we saw is the appearing of many articles on the literature, and many of them really not yet peer-reviewed. Peer review is one of the most important pathways to analyze the data that are appearing on scientific journals. And this was due to the pressure of time and the pressure to share news. This was a new disease, so news and information needed really to flow pretty soon. Analyzing what came out from this literature study, what we realized that many of these studies were pointing to a relationship, a correlationship between the number of deaths, for instance, due to the COVID, and the better quality, as simply showing that this number of deaths were increasing with the deterioration of the air quality. In reality, correlation of these two things do not show the existence of the cause-effect relationship. We found that many of these studies were simply statistical approaches, but in reality, there is a complexity of factors that are really influencing the COVID, and therefore the complexity was very important in that. We saw the fact that air quality was linked to better quality, was associated in many cases to places where we had a very high density of population. Therefore, maybe air quality was acting as a proxy of the fact that there were many people in the same place, and we know the person-to-person contact is very important for the spreading of the disease. Now, many countries are also publishing their data, but there is no clear unified definition of, for instance, what we mean with COVID-related death, so that this non-homogeneity of the epidemiological data set really makes it really difficult, this analysis. We needed to have a large amount of data to be really statistically relevant. And then whenever we take action to mitigate the problem, somehow we influence this database. So it's not really very easy. But on the way forward, we thought about the suggestions to policymakers. First of all, to make it really developing uniform and international agreed protocol in order to have the same definitions, and therefore having the possibility of relying on a large data set. For the analysis of data, for the study of the environmental factors and COVID, air quality and COVID and so on, there is the need really to have multidisciplinary research teams that really combine these statistical or mathematical studies with really studies in laboratory and field experiments. We needed to have a longer time series to make really robust the statistical analysis. And if this relationship is really found between air quality and COVID, these can be put into epidemiological models to make it even more accurate, the prediction for the future. And all this has been published into this report. Thank you.
Okay, thank you, Elisabetta. It's clear indeed that the wheels of science, so to speak, had to turn very quickly to respond to a number of the reflections that were, you know, obvious in society. And I think you very nicely illustrated how, yes, peer review sometimes takes a long time, but there are pressures not necessarily from the political actors, but also from society at large to get the information that people are craving for, and how to embed that in a better information system towards the future and make that possible, I think is a critical element indeed. And that's where maybe Vincent-Henri, you also come in, because of course with Copernicus, we've got a brilliant new technology that we can use and gives us a very different type of almost daily, hourly information on these issues compared to the traditional in situ monitoring. So could you introduce us a bit on what you have been observing in the camps program and how that has brought information to society and policymakers when it comes to COVID-19 and air quality. Over to you, Vincent-Henri.
Thanks, Hans, and thanks, Elisabetta, for this introduction. I would like to start first with a word of compassion. COVID-19 is a very serious disease, and maybe some of you have been directly or indirectly affected by this disease, and we are talking about figures, but in the end, it's people. So I would like to have this word of compassion before starting. Yes, you're fully right, Hans. The amount of information that is already available on a topic like air pollution and trying to relate that to exposure and to health impact has increased a lot in recent years. It's not only the amount of observations. Of course, there have been some satellites that have been launched to monitor some of the pollutants and the greenhouse gases as part of the Copernicus program, but also by colleagues in North America or in Asia as well. But it's also the openness of data. So some of the in situ regulatory observations that we are used to share in Europe were not shared as much in other parts of the world. And I think we see now a general trend for opening up this data. So there is more data available, and this data is more widely shared in real time or in near real time, that is within hours. The other thing which is developing a lot is the availability, and everybody knows this, of so-called Internet of Things information. So that's road traffic information, that's mobile phone information about what is the speed at which people are driving or walking, etc. So there is lots of information that is becoming available, and this information is also something critical to assess how human activities have been changing as a result of COVID, or more precisely as a result of the measures that have been taken. And the third aspect of the capabilities that are now available, that were not available, I would say, 5 years ago, is the availability of advanced numerical models to make sense out of these different streams of observations. Very often I use the example of blind people trying to describe an animal in front of which they are. So the first one will see the trunk, another person will see a foot, another person will see a tail. And then it's by discussing together that they will define, yes, we are in front of an elephant. And what we ask numerical model to do is exactly that is to use this information from satellite observations, from ground-based observations, from Internet of Things observations, and we try to make a sense out of that to deliver more readily accessible information. And my last word is to say that things are often more complex than it seems. In particular, and it is well known in the air quality area, that not only the emissions determine the concentrations of species that people breathe, it's also the weather, in particular the mixing within the first 1,000 meters of the atmosphere. And if you don't disentangle the weather and the emission aspect, you may come up with completely wrong estimates. So it's very important to do this estimate properly. We have lots of tools at hand, but again, I would like to second Elisabetta and your statement about science and the fact that when some questions are complex, it needs a bit of time to formulate the answers, and then from the peers to evaluate the accuracy of these answers. So it took some time, but we are now coming up with a pretty clear vision of how changes to lockdown situation have affected air pollution and greenhouse gases as well.
Okay, thanks, Vincent-Henri. Maybe a first sort of point of clarification for both of you. When we talk about air pollution, we know that air pollution has a variety of sources. There are a variety of key pollutants involved that have a variety of impacts and exposure pathways on our cells and on the environment. Could you disentangle this a little bit? Because, you know, are we talking about sulfur dioxide? Are we talking about NO2? Are we talking about fine particulate matter? Where did you see the biggest impacts, and where do you see the biggest impacts also connected to the measures that were taken? And I know we framed this as a transport session today, but I'm sure that both of you have a broader vision on that, because not all air pollution is the same. And it doesn't always end up in the same way in the environment or in our body. Maybe Elisabetta, if you could, from your research team's perspective, throw a bit of light on that.
So first of all, we analyzed indeed the data from our site, which is our semi-rural site at the edge of the Po Valley in northern Italy. But we have done this work together with the people of the Lombardy Environment Agency, analyzing also the data in the city of Milan. What we came up is that during the lockdown, indeed, there was quite important reductions of NO2, and NO2 was, this reduction was indeed mainly due to the reduction of the traffic. At that time, the Po Valley was in the area where we had really a complete lockdown. So indeed, the transport was really changed, the pathway of transport changed a lot. So we saw this decrease by 40% in the semi-rural area, 30% in the city. So quite important decrease. What is important is that we analyzed also the particulate matter. And the particulate matter concentrations did not decrease that much. However, we saw a change in the nature of these particles because we were evaluating certain properties of this particle. We realized that luckily the sources of the particles were changing, and then moving from particulate matter rising from or directly from the traffic, or formed in the atmosphere by the gases from the traffic, to the ones emitted by the domestic heating. So in fact, what we saw, and then this is not surprising to think, that the people indeed were not traveling. They were staying home. That were still the months in which winter was there. So the domestic heating was really going up. And this was also seen by an analysis done at the European level, taking 17 stations. We saw the same about the PM. PM had changed the nature in the meanwhile.
So a very strong link with the shift in human behavior, one could say, induced by the measures. Vincent-Henri, do you have observations on this point?
Yes, so we've been trying to, first of all, there have been a tremendous number of studies that have been ongoing in all the European countries and in all across the world, actually. We've been working with the World Meteorological Organization, and we did a survey in April, and it basically turned out that more than 100 of groups were looking at this question of air pollution, and some of the things that we've tried to do in Copernicus was to try to make sense out of all this body of work to see what is the generality of these aspects. And joining forces with the EEA, we've been looking specifically at Europe, all the countries in Europe, and trying to design different methodologies to assess how air pollution has changed as a result, and air pollution in terms of NO2, but in terms also of particulate matter or of ozone. And to do that, we've used satellite observations with a methodology to offset the meteorological variability, which was also done for the surface. And we were able with that to assess some changes. So finding figures very, very similar to what Elisabetta mentioned for Italy and Spain, and figures with a less substantial reduction in other parts of Europe, especially in the north of Europe, where there was no lockdown, formerly national lockdown measures. And finally, what we've done is to use this information about the different emission sources, so traffic, energy production, shipping, domestic heating, industries, and putting that into our model. And what we did with this model was to make simulations with normal business as usual emissions, and then make simulation with the emissions as we think they were during the lockdown period, and make the difference between those two simulation of the air pollution situation. And it was very, very interesting to see that the consistency between the observation-based estimate and the model-based estimate was really really very close, and showing this gradient of effects for NO2 ranging from 40-50% to almost no effect in other places, and for PM something which is more between 12% and 0% all across Europe.
Okay, before we look at a first set of questions that come from the audience, maybe, let me zoom in a bit on two elements that you mentioned, Vincent-Henri. That's the shipping and the aviation, which are, of course, two sectors. Well, air travel has dropped enormously, as we all know. But also, if you look at shipping as, you could say, the conveyor belt of the global production chain and consumption chain, what are some key observations there, or are we not able to disentangle that? Because I know of some of the maps that we see in air quality where you can actually see from space the shipping lines, and you can see, so what sort of data have you been able to produce on those two sectors?
Yeah, so for aviation, it is possible, of course, to have access to air traffic information in real time. So we've been able to see the activity of main airports in Europe, focusing over Europe, and to see that the drop was 95%, recovering slightly, but still very low. So there is external information that really give us a direct handle on the activity regarding aviation. And for shipping, it's the same, because ships have transponders for regulatory purposes. And so we've been able to see, in particular, that the cruise shipping, which is important especially all across Europe, but especially in the north of Europe, that basically was entirely abolished, while some other shipping activities were not so much changed, because all of the orders, online orders, and the need for supply chains, this did not change too much. So overall, for shipping, what we've seen is a reduction overall of emissions of the order of 20%. At the maximum of the lockdown, to be compared to the 95% for flights and the 70% maybe for road traffic.
Okay, before we dive into the measures and whether this is then a way forward to address issues of environmental pollution and climate change, let's look for a first round of questions from the audience. Gulcin, do we have some questions yet?
Yes, we do. Actually, we have questions from our Zoom participants, but we also have questions from our Facebook followers. I'll try to group them into two. There are some that are, Amelie from our Zoom meeting is asking, says, EEA is regularly publishing reports on premature deaths related to air pollution in Europe. Do you have any estimates about how many air pollution related deaths could have been avoided, prevented because of lockdowns in Europe? There's also a question again on the impacts of the measures and on the environment from Yasmin, asking what are the impacts in the short term, since the long term there's no significant change. Is there any study released recently about that? And maybe before I give you the floor again, there's a clarification question, I think, from Christian, again from Zoom, asking whether coronavirus detected on particles, if it is PM 2.5 or PM 10, aerosol. It's important for the range, he says.
Okay, maybe Elisabetta, first you, and then Vincent-Henri, if you can respond to some of the questions, and I'll take the EEA premature deaths estimates then last. Okay, Vincent-Henri, or Elisabetta, sorry.
Thank you, Hans. Regarding I started with the last one, which is the one on the range for the particulate matter. Indeed, it would matter. I think, if I recall, it was a PM10, but I'm not so sure that I recall it well. So I have to check that. And then indeed, it was on the airborne particles. So the aerosols that we found in the air, just for the information on that. Gulcin, could you please repeat the second question so that I think I missed?
Sure. There were two questions, in a way, a bit of a comment saying that there's no significant change in the long term. What are the short-term impacts, and if there's any study released recently? And I can maybe just add to that thing, because it's a bit linked to what you were discussing. Thanasis from our Zoom meeting is also asking if you can give an indication regarding ozone trends during this period as well.
One thing that I think that for the studies we saw about the ozone, particularly the last one, we saw actually an increase of ozone due to the fact that there was this decrease of NO2. This is ozone is formed in the atmosphere. It's not a primary product. And then it is a result also a very quite a balance of compounds in the atmosphere. And this is what we have been observing. Vincent-Henri, would you like to add something on this?
Yes, so I agree on ozone. So we've seen, especially in May, because this was the end of the first big period of lockdown. So in May, certainly we've seen slightly enhanced levels of ozone that are compatible with the decrease in NO2. Then on the body of research on the effect of COVID, of the contribution of air pollution to COVID severity has been starting, I would say, in a very rushed way. As Elisabetta mentioned, there were correlative studies that were really not that relevant. Now we see a growing body of evidence that show that air pollution may be contributing to 15 to 20% of the COVID death, mainly through the weakening of the biological barriers, so the immune response function. So that's first quantification, and now we have a number of papers that show this type of value. Otherwise, in terms of short term versus long term, I think what we didn't see the emissions in the period where most of Europe was without lockdown in the summer. All the emissions didn't go back to business as usual. So there were still some reduction. So at the heart of the lockdown for NO2, for instance, we were at maybe 40–50%, and then in the summer it didn't go back to normal, what we would expect on a normal summer, but it was something like 10 to 15% lower. So showing that people were behaving differently already. And now we see again that the numbers are decreasing, but not to the level of the first wave. So somewhere in between, as far as we can see now. So this is a complex question, because there are lots of mechanisms which are at play. So we said, okay, people, there is lockdown, so there is less car traffic, but there are mechanisms that go the other way. For instance, people don't want to take public transport not to be close to others, so they will take their private car. So depending on the countries or even on the region, the situation well, requires some attention to really sort out the figure. And I let Hans answer on the positive side, which is the benefit due to better air quality for reducing mortality.
Yes, well, the answer there is no. We have not made those estimates yet. We do that on an annual basis when we do our report on air quality in Europe. And we do that with established methods where we work together with the World Health Organization. So we will do this in due time. But I think it's a little bit like the question on what is the link with climate change. If you really want to know, you can model it, you can make estimates, sometimes even guesstimates. But at the end of the day, you are waiting, in our case, for the official data. And then you look at the normal way in which you then calculate what the impact is. So we of course are working on that, and our specialists have an expert opinion based on the data that we see, but we have not come with the official numbers there or the official estimates. I think indeed, as Vincent-Henri said, you need to be on solid ground when you do that. Otherwise, I think you are not polluting the air, but maybe polluting the public debate on these issues, which also has its own type of consequences. Gulcin, do we have other questions?
Yes, maybe just to follow on the same clarifications around the links between the virus and particulate matter. Franco from our Facebook transmission is asking if there's any epidemiological research which can find a link between the virus and particulate matter and whether COVID can remain viable on aerosols for 3 hours or more. Zeynep, again from Facebook, is asking to Elisabetta, based on the Milan example that you have given, whether you considered meteorological conditions effect as well. And Lena is asking if you could identify any change in nitrogen dioxide due to reduction of fertilizers used during spring, besides the traffic source reduction. So whether fertilizer use had an impact as well.
Elisabetta.
So yes, I started with the analysis of the data, and indeed, exactly as Vincent-Henri said, done at European scale. Also in our case, we had to disentangle the meteorological impact to the reduction of emissions. So this is very important. And indeed, it was exactly when March arrived and then the lockdown started, we actually saw immediately the decrease of the pollutions also in our area. But in reality, these decrease of concentrations were due to the change of weather pattern. Spring was arriving. It was not due yet due to the reduction of emissions, but to the reduction of to the change of weather pattern. So we had also in this case, and basically using the information from the CAMS model, so that the link with the activities of CAMS, we had to disentangle these two. So indeed, yes, we had to make this happen. I do not recall if we have done a particularly analysis on the changes also of the agricultural side, but I do not recall from the analysis that we saw such a change in other activities that were not really related to the traffic and consequently to the increase of the emissions due to the highest domestic eating in the same period.
Vincent-Henri, any part of the questions that you want to respond to?
Maybe just to make a short point on this, I think more fascinating than something else, a question of PM acting as vector for the virus. The literature that exists so far is quite clear and quite convincing for indoor exposure. So there are quite a number of work that show that in indoor environments, it is possible for the virus to attach on fine particulate matter, and this had been measured in situ. What has not been assessed, to my knowledge, is the dangerosity of the virus. So whether the virus clings on the particles, but whether the virus can infect, I think is still an open question. And outdoor, I think the question is even more open. So far, I don't think there are convincing work that show that aerosol outdoor could contaminate people, or either directly or indirectly, that is with the aerosol carrying the virus being deposited on surface. So far, what the consensus from the WHO is that if there is a route for the virus to be carried on particles, outdoor it's very, very minimal. And indoor, anyway, it's being, well, when it's in hospitals and things, this is under control, of course. But yeah, for some reason, this question of particles playing as vectors, a role of a vector for the virus has been high in the news. It's true that for some diseases, it's a very important process, but for the COVID so far, evidence is very, very limited.
That is confirmed by our colleague from Belgium, Frans Vierens, who says that no SARS COVID-2 virus was found on particulate matter collected during the first COVID wave in Belgium. Okay, I suggest that or Elisabetta, you wanted to intervene here?
Just to add another piece of information. And in fact, one of the things we have done, although it's just a theoretical study, so a modeling study, we analyzed the probability that the aerosol emitted by an infected person, so really through breathing, talking and so on, could actually coagulate on a particle coming from the pollution sources outside. So we are always talking about outside the condition, not indoor condition. And then we evaluated that probability, and we evaluated the probability if, and only if, this particle was still capable to bring an infective agent within to enter our lungs and deposit. So it needs to be a certain size. And this probability was very low, and it was almost independent by the concentrations of the outdoor particles.
Okay.
So this mechanism seems to be of a low impact as far as we can see. Okay,
thank you. I suggest that we move a little bit towards what we can learn from the observations that both of you have been talking about, because we now have seen in probably the largest involuntary experiment ever with teleworking, but also with changing our mobility patterns, with changing all sorts of things that we do in our free time, that we do indeed have a massive impact on air quality, but also on greenhouse gas emissions, on other things. Yeah. It's of course not the case that this is the desirable way in which society is dealing with air quality or with greenhouse gas emissions. But are there, from the research that your teams are doing, are there lessons that we can draw? Are there things that we can take with us as we think of shaping and implementing various aspects of the European Green Deal, as we think of the investments that we are making through the stimulus package Next Generation Europe, which has a very clear green sustainability angle to it? What are the things we can learn from this that may go beyond this pandemic and the crisis responses that we unfortunately are living through now? Vincent-Henri, if you could go first.
Yeah, so I will not comment too much on the aspects I'm not really expert on, which is what we learn as individuals or as organization in terms of allowing more teleworking, reducing travel, in particular related to work, to show that meetings and conference can happen online, and they're very good as well, they're effective. Where I would like to comment is on this real life experiment, as you've coined it very, very well. I think it's extremely useful for us developing modeling systems to assist policy makers to basically know about the cost benefit of certain measures. And to do that, in order to support the design of effective policy, we need numerical models to test different changes that can be made to the patterns. And so far, we've been working in a mostly theoretical world and having the possibility to evaluate these modeling systems on this life-size experiment is really important. To my mind, there is only one other occasion where this could be done, and this has been done a lot. It was for the Beijing Olympics. As you know, for the Beijing Olympics, the Chinese authorities had reduced strongly many activities in and around Beijing, and it was possible to see some drastic change. And these have been used a lot to see if models are capable of representing that. And now we see exactly the same with the COVID. Because the change in emissions are complex, it allows us to evaluate the model in a very thorough way. And in the future, we will be better able to answer some questions. So if a policymaker in Germany says, what if I do an incentive for public transport and reduce by X% personal car transport, what will be the benefit in terms of NO2 or PM2.5? And the data that we are seeing and acquiring will help a lot to be able to answer more accurately to such very practical questions.
So in other words, this very unfortunate societal situation to which you referred also when you took the floor first has positive impacts on our knowledge base and our understanding of cause and effect relationships between human behavior and the natural systems in which we operate. Elisabetta.
So I started these answers from a philosophical perspective. The fact that this unfortunate situation that of course cannot be sustainable. We cannot lock down our activities, not in the middle, not in the long term. But actually the response showed that there is a collective capacity and willingness to face a problem. In this case was and is still the COVID. Provided also the fact and showed that indeed human activities are causes of such a high level of pollutions. And in fact, changing this pattern showed immediately the effect on such a level. However, as we have seen, for instance, in the case of PM, was showing to us that in reality, changing a pattern, decreasing emissions from traffic, in reality carried with it the fact that the emissions from the domestic heating were higher, and therefore was not really tackling the PM problem. An holistic approach to air pollution is necessary, so that the decrease of the emissions goes hand in hand in many of the sources. And this is basically also what is at the base of the European Green Deal. The other thing that I also can point to the fact that when the lockdown was over, but really people were pushed by their fear to go, for instance, on the public transportation, and came exactly instead of going to work with the private transportation. So again, increasing the pollution problem was very much important that in reality, conditions were appearing of more bicycle lanes, more other alternative ways of moving within the cities were put into place. And this is also the way to really push people to change their behavior. So it's really a collective result, can be a collective result.
Yeah, one of the links that we can make, of course, is with a term that has been used so often in the last 5 to 10 years, that we should pay more attention to behavioral science. Well, this massive involuntary change that we've been going through should be a laboratory now also, not only for the modelers, as Vincent-Henri said, but also for those behavioral scientists who are looking at it. I've heard also about people now looking at more fundamental understanding of how we relate to ecosystems and biodiversity, how people have gained appreciation for nature that is close by and the beneficial effects when they have limited capacities to travel somewhere far away or to do all sorts of other activities. The idea that we will rethink working forever, yeah, it will not go back. There is no going back to normal. There is only moving forward to a new sort of normal. So all of these things, of course, play into the agenda that is put on the table by the European Commission under the Green Deal as well. Gulcin, any other questions from our audience?
Yes, actually, just maybe because you touched upon some of the issues, Maria Georgina from our Facebook streaming is concerned about the pollution from burning wood. So Elisabetta, you were mentioning domestic heating and its impact on forest and biodiversity in general, considering especially that forests also provide clean air. And Vincent, again from Facebook, is asking if there are national government figures and statistics about teleworking, so the change in this kind of behavior and going to work, although it may not be homogeneous, but it would be an interesting kind of data set as well, he says.
Well, picking up on the last point, I don't think, Vincent-Henri, that you can monitor teleworking from the sky. Or that, but I think this will be part of a body of knowledge that we will use to evaluate, analyze, assess, and understand what is happening now. We do know that, or we can make assessments of the number of people that have been teleworking, and there will be massive analysis by scientists of all the various aspects of teleworking. From the mental to the productivity to what it means for energy use in the home environment to the environmental impacts, climate impacts, all of that. But I don't think we monitor that from the sky. Elisabetta, I don't know whether you have any in your research team. No. Those are, I think those are great questions, because yeah, I mean, if you look at the literally hundreds of millions of people on a planetary scale that have changed their working habits, after 20 years of debating teleworking by labor sociologists and labor psychologists and organizational theory people, and we now have again an unbelievable basis to really analyze what is possible and what is not possible. If we think about air quality in Europe, it's been a story of slow progress. Yeah, over 2 decades, 3 decades, I think stimulated primarily by binding European legislation, informed by science, but we still are not reaching the World Health Organization standards. 80% of the urban citizens in Europe are still living in air quality that is deemed not healthy by the World Health Organization. Now, Europe is looking at air quality standards for the future that would align us much more with those World Health Organization standards. Elisabetta, you do quite a bit of the fundamental research work with your team. To what extent have debates and discussions and scientific research now on this COVID crisis, have they permeated the debate on where Europe should set standards and what measures we should take to be better aligned with those World Health Organization standards?
Not so much about the debate or the levels. Indeed, there are many concerns around, because indeed we know very well that the European level are in many cases well above the WHO standard. Therefore, there is quite some concern by people about all this and asking why Europe still has such a high level compared to WHO. But I think that this issue of really further decreasing, you said, after these 30 years of improvement of air quality in Europe, now the there is quite a strong willingness. Again, we nominated here the European Green Deal, but I think under the European Green Deal, there is a quite strong push for the decrease of emissions for air pollutants. What is really important to see that beyond what is done also in the zero pollution strategy, where of course air plays a role. And then we talk about revision of the air quality standard, but we tackle mostly the major sources of air pollution. One study is very interesting, and the impact assessment done for the preparation of the new targets, the climate targets for 2030 for the European Union, of the 50% reduction of greenhouse gases, shows that the same measures would allow by 2030 a further reduction of 60% of air pollutants compared to 2015. So the way ahead is really, and then it is an optimization really of the measures to take, tackling climate change from my side and air pollution at the same time.
The so-called co-benefits discussion. Vincent-Henri, that was a nice bridge that Elisabetta made with the question for you, because you're, of course, on the atmospheric service of Copernicus. You're working on that, leading that work. You are in the perfect position to also comment on climate change and greenhouse gas emissions. We learned that this is the year that we've seen the largest cut in greenhouse gas emissions. And then people say, if you look at what it took in terms of closing down parts of society, this is in fact a rhythm that we will need to be in line with what scientists are telling us to go to a zero carbon economy. So a tall order, but could you also comment a bit on what we observe globally and worldwide in terms of the climate observation that you are doing?
Yeah, yes. So from an angle, the impact of the COVID on the concentrations, for instance, of CO2 or methane, the key greenhouse gases, may seem to be fairly minimal. However, at variance with NO2, which is a short-lived species, so it's emitted and one day later it's back deposited. CO2 and methane, these greenhouse gases accumulate in the atmosphere. And even if there is a strong reduction in the emissions, fresh emissions of these greenhouse gases, it takes a very long time to really impact strongly on the concentrations. And the problem of the climate crisis is that what matters are the concentration in the air, not the fresh emissions. So what we see, the same processes as Elisabetta was mentioning, emit pollutants and greenhouse gases at the same time. And it is possible to design measures that are win-win or co-benefit situation, as you said. But the problem of the climate issue is that it's much longer term. These type of emissions have to be reduced on a very long time frame, and that's why societal changes, habits changes that can make cuts or a certain degree of cut in a certain emission sector long term are really needed for climate. The issue is that the clock is ticking. The atmosphere is full of greenhouse gases, and unless the problem is addressed now, there will be nothing to stop the changes associated with greenhouse gases. So I think this crisis is telling us that some measures that we thought would not be possible or would not be acceptable, I would say, they are acceptable and they are bringing also benefit. And I think it gives some more credibility to the palette of tools that policymakers and the national level administration can take to address this climate problem. The benefits are more long-term than air pollution. So air pollution, traffic stops. The next hours, NO2 drops. For climate, it's not the same. Levels of CO2 and methane have to be reduced long-term, and for that we need measures that are sustainable and accepted by the population.
Okay, thank you. And I asked the question also to make sure that we could indeed make the distinction between a slowdown of adding greenhouse gas emissions compared to the build-up concentrations. And you mentioned that it's 12:05 when it comes to the mechanics of climate change. Well, it's 2:55 for this session, and we like to conclude on time out of respect for the audience. So I would like to ask Elisabetta and Vincent-Henri to give a sort of last statement. If you could send a key message on what this COVID-19 pandemic has illustrated in your domain of expertise, that would be really nice if you could do that. So Elisabetta, first you.
I would make a provocative ending statement saying that although we can imagine that air quality might have an effect or make it the effect of COVID more critical than without such a bad level of pollution, what we should never forget is that actually air quality is a better quality is a killer per se. And then we should not forget that those almost 400,000 people premature dying in Europe for better quality. And then we just for that, we have to remember that those levels of pollution needs to be going down to protect citizens' health.
Okay, thank you. That's, I think, very clear. And if the unfortunate COVID-19 pandemic can also draw attention to that very fundamental fact, that is important. Vincent-Henri.
Yeah, I would stay on a very general or philosophical statement to say that in everything there is something to learn, and in this extremely big thing, which is the COVID that happened to humanity, there is a massive amount of things to learn. And maybe it came at the right time again for this question of climate change, bringing some solution, I think, closer to reality. And the other benefit I see is the massive interest from the general public for facts. And I think for some years we've been discussing about alternate reality and things. And in the COVID crisis, I have been really impressed by the appetite of the general public about knowing the figures, knowing the facts, and I think this is very good. Evidence-based decision making is probably the best that we can wish.
Thank you. I couldn't agree more. Of course, if we can have debates that are based on rationality and on facts, at least we have a common ground, and then we can still differ in how we should respond, but at least we understand that part of the reality is non-negotiable through ideology or through any other part of people's reality. I would like to thank Elisabetta and Vincent-Henri for this session. I would also like to thank the audience for being with us. This session is recorded as all the other sessions, and it is available in our debate corner on the EEA website. Of course, also thanks to the back office, our team that is making this possible. And I will be happy to be with you in 2 weeks for the next session on this COVID-19 environment and climate debate series. Thank you very much. And till the next time, goodbye.